Hello,
Hello, madam. Hello.
hello,
Hello. Audible, na, madam?
hello.
Yes.
Good afternoon, sir.
Good afternoon. We can start?
You can start the session.
Okay.
Okay, sir.
Yesterday we discussed about HART protocol based transmitter. Now we'll discuss about a field bus transmitter. This is today's what we will discuss agenda, and if time permits, we also cover wireless HART transmitter. So field bus transmitter. Before that, just I will give you the evolution history: analog transmitter, HART transmitter, field bus transmitter, and wireless transmitter. So transmitter yesterday we have seen transducer, transmitter. You can see the change here only: analogs, HART, field bus, like this. Input signal, output signal. Then you have, when it is a standard current signal, that is analog transmitter. If it is a HART signal, that is a smart or HART, means analog to digital signal. And then only digital signal, then we call as a field bus. And if the signal is wireless, then here we can see the without wire, means the wireless signal is there, then we call as a wireless HART transmitter here. So analog transmitter, pure analog signal; HART transmitter, digital plus analog. In the field bus there are two options: one is the Profibus protocol, and another is the foundation field bus. So Profibus transmitter and foundation field bus transmitter. Analog transmitter we have seen yesterday, so I will go fast. Yesterday we have seen this pressure signal conditioning in 4 to 20 milliampere, and we have seen the electronics also there: sensor board, main CPU board, display board, and their functions. So same thing is here. Just for refreshing fast, this sensor gives a micro farad signal to the signal conditioner, amplified, furthermore process. Then we discuss about importance of 250 ohm resistance, so current loop. So across the 250 we are getting 1 to 5 volt DC to DCS and recorders. Across this we go the control room devices. So smart transmitter, the changes is the microprocessor and EEPROM here, A to D, D to A. There are remote communication, diagnostic self-test functions are available. That yesterday we have seen. So I'm going fast few slides. Say there in the HART transmitter sensor module, electronics module, CPU module, cables are separate. We have seen yesterday, and their function. Hmm. So Bell modem is a very important for HART, and we get a 4 to 20 milliampere and digital signal communication here on the 2 wire. So if you see the real time versus sampling, analog signal versus digital signal, so you can see the pressure is changing. Then the pressure signal is converted to analog signal. You get in this way. However, when we sample this analog in the digital, you can say, to convert it to digital, you can get 4 to 20 milliampere output like this smart transmitter, and you can see the changes here. Means analog plus digital signal. So A to D, D to A convergence. Magnitude of a sensor output is sampled. Magnitude of a sensor output is sampled in a multiple times per second to give a discrete values. You know, A to D, D to A conversion principle, same thing. Mm. So analog output will undergo small step change with respect to the sensor output. So these are small step changes. Mm. So HART protocol we seen yesterday. Logic 1 is 1200 hertz, and in the digital signal logic 0 is 220 hertz. So HART protocol uses the frequency shift keying electronics based on Bell 202. Bell, this modem is a proprietary of the Bell to superimpose the digital communication on 4 to 20 milliampere current loop. So I told you this 1200 is logic 1, 2200 is logic 0, and you see this signal 4 to 20 milliampere and how it is a digital communication signal comes superimposed. So average modulating current signal is 0 in this three. Therefore, HART protocol does not affect 4 to 20 milliampere current signal. The voltage or current in the wire pair represent one process variable. So this is a current loop. Field instruments modulating current signal and smart transmitter. So this we have seen. So like this in the DCS controller and these devices are connected in this. This is the what the transmitter terminal block back rear side of the transmitter, and you are connecting these wires, or you can see here this is what power supply is processed through the transmitter. So here in this loop transmitter and power supply is there. So 4 to 20 milliampere modulating current signal is flowing in this. Average hertz voltage signal is plus minus zero point 0.3 volt, but hard circuit recognizes at least plus minus 0.125 volt as a valid signals. So here for this purpose only we put minimum 250 ohms resistance. So modulating voltage communication signal you get here across this. So E is equal to IR. So zero point 0.5 into 250 ohm is equal to, you get this signal value plus minus 1.125 volt. So that is the logic HART communication signal. So why 250 is answered here. Hello, hello, hello.
Ah, yes, sir.
Yes. So when we connect the communicator here, this is a HART communicator. Yesterday briefly we discussed across the 250 ohm. To establish communication with the HART communication require 250 ohm here. So communication signal riding on 4 to 20 milliampere analog signal. That's what here. So physical layer, as this HART communication protocol has a four layers as per OSI model. So physical layer is Bell 202 FSK. Transmission rate is 1.2 kilobits per second. These are the characteristics of the protocol. When you see the in the industry, this junction box study I have shown, marshalling panel also we have discussed. I think you have seen marshalling panel or not, but I will show you. In the junction box, we connect the transmitter like this, indicators display, chart recorders like this, control system signal goes like this through power supplies. So in the remote communication with the HART protocol, where to establish communication with the smart transmitter, HART communication can be connected to any points in the loop having at least 250 ohm loop resistance. As this is the loop, so definitely it is a more than 250. So no need to extra 250 ohm. So normally in interviews, this question is asked: why 250 ohm is resistance is in the HART communication circuitry? The answer is because this protocol, as you have seen the earlier slide, protocol has been designed accordingly to get a superimposed signal. Therefore, without that, inside the loop, if uh, resistance is less than 250 ohm, we will not get modulating signals. So you can see in this control circuitry loop control system consumes load 150 ohm. chart if it is there 100 ohm, right? Then this recorder here. So already you can see here 150 plus 100, 250. So hard communication for a smart transmitter. This is your transmitter and this is your communicator. And in the communicator there is a memory also. Then data pack is also available. Hmm. Communicator must hold the device descriptor file for that particular device model to establish communication. Means for this particular manufacturer's device description has to be there. Means there files has to be there, or you have to upload or download from their sites. So, oh sorry, hello.
Hi, yes, sir.
I think this slide is visible.
Visible, but some part is
Scroll
missing.
down, scroll down. Just a minute, why it has happened, I don't know. Now it's visible, no?
No, total is not visible. Part is visible only.
Okay.
So
The
now it is
anime,
visible.
actually it is animated, that is what.
Yes, now it is totally visible, sir.
Uh,
Now it is visible properly.
Right, right. Some part is with the link, animation link, so that way it is missing sometimes. So in the communicator is very, very important devices as far as a transmitter diagnostics or testing, calibration, whether it's a transmitter nowadays for wireless transmitter, foundation field bus transmitter, or any field bus transmitter or hard transmitter, communicator is required. And the in the industry now, communicators are available with all three uh, protocols based transmitters. So field upgraded well means the latest device versions and software versions can be added. Mhm. So this is something about a communicator. Communicator has a memory 275. This is a model number 275. Then this is actually immersion communicator. 275 was a first version, then 375, then 475. Now it's the latest also AMS type communicator is there. As I told yesterday, it is now available with a big, a larger screen like iPad type device, but it is industrial grade. So uh, this memory, module memory, stores the communication configuration for future use and DDs. This is a working memory, holds the connected transmitters configuration. And you can see this data pack is optional, hold transmitter configuration for future use. Mm. So multi-dropping is possible. Means you can have certain, not normally industries not using multi-dropping, only when your small plant, small application, where there you can use this multi-dropping. But there is again limitation for maximum 11 or 12 transmitters. You can multi-drop it on hard communicator. Here it is mentioned 15, but you can load at least 60%. So I think then maximum 10 transmitters you can use it for multi-dropping. So this is the communicator which communicates with the this transmitter. As I told, you can access through your PCs, laptop, and for that purpose, you require modem to be connected to the PCs, and you can connect the transmitters in the field for maintenance. Asset management, uh, online communication, and diagnostic provides a maintenance and engineering the tools for efficiently manage plant assets. Means as your DCS workstation busy, so and DCS directly not accessing asset management means hard modem or hard softwares. Your hard signal analog part DCS cards are taking, but your digital which you communicate with the transmitter, that features in the DCS cards are not incorporated by none of the manufacturers. So everybody suggests for that separate workstation with a hard modem, hard software, connected to the critical your transmitter device, and you'll get such type of screens as that one. So AMS is the software along with transmitter modem, hard modem. So you can connect transmitters meters online. And advantage is that all transmitters you connect to this AMS workstation. And as I told, there is a converter is required. Through this, it is connected. Mm. So these are the some advanced features beyond a communicator. Communicator is a very handy tool you can carry for maintenance in the field. AMS is on your asset management, means how many transmitters are there, then configurations, entire thing, because it's on PC, so you get naturally get, having a sufficient memory. You can make a create a reports for your audits and all. So that benefits you get much more in the AMS facility. But you cannot go to the field along with the AMS tool like PCs or laptop, because in industry, the place where we are working, it's very congested. So as I told, marshalling panel is this much. This is a marshalling panel. Then elco board, each board can tap devices. This is the elco board. I was talking this elco board in the DCS is for conversion, means signal conversion, signal repetition and conversion, both and isolation. Three functions are there. So through this board, incoming cables for field devices, two DCS cables, and you can see to the multiplexer here, signal multiplexer. Each mux can you can see, and you can see here. This is your workstation. You are connecting here through converter, and this is what you are taking signal from here. So actually, as I told, in directly DCS network we cannot connect, but the DCS signal coming from the field, which is here in the DCS marshalling cabinet or ELCO board, from there we can tap the signal for AMS workstation. That is what it is mentioned. So smart transmitter operating range is normal range is 4 to 20 milliampere. And yesterday I was talking that diagnostic is based on the current, over current or under current. So if your current is less than 4 or more than 20, and within the 20.8 and all, the diagnostic signals are displayed or generated. So pressure drop below 4 milliampere, output current fixed at 3.9. Pressure drop above 20 milliampere, so output current fixed at, so then alarm message displayed. So for both the cases you will get alarm. So how the alarm is generated, that is what it is mentioned. So hardware failure alarm, high or low. So you'll get a message either high or low. So when 3.7, for example, then you'll get a pressure drop low. So you'll get here a hardware alarm. So advantage of this smart transmitter, process variable rating, you can read the process variable when the 4 to 20 points are exceeded. So benefit of smart transmitter against the analog transmitter: high accuracy, more features, wider rangeability, simplified maintenance. You'll get a better accuracy, more features means diagnostic features, wider rangeability. You can have a range change of the transmitter, and as so maintenance is very simple, easier commissioning, multiple sensor readout, better electronic stability. Now we'll switch to the foundation field bus or field profibus. The FF means foundation field profibus, PA. Profibus has a two option, Profibus PA and Profibus DP. So equivalent to the foundation Profibus, we can say Profibus PA. Pressure temperature can be used for control operation, pressure, temperature, level and flow. Supports intrinsic safety with a bus power device. So these are a intrinsic safe device. Yesterday we discussed about what is intrinsic, more zone 0, zone 1, or we can division 1, division 2 in the European standard. Like this, the safe area, hazardous area. So these Philbus devices are available in the safe area as well as hazardous area. This color shows hazardous area. So when we say Philbus network, what is the difference? Philbus network, how we connect is a digital signal. So this is a power supply, power filter, terminators, H1 segment. You have this network devices, control wall, transmitters. Control means positioner. I'm talking. These are couplers, and here also you can see devices are connected through junction boxes. Local operator interface also you can connect. These are junction boxes, and finally you can terminate this, and you can have here this type of a configurator, or we can have a handheld also operator interface. So Fieldbus network is IC115-2 standard. When we say Fieldbus is a digital signal, no analog signal, so definitely we enjoy networking topologies, different topologies. So you can see a DCS controller. You can connect like this as a tree topology. Here you have junction box and just you connect this. This is the junction box. This is a Fieldbus junction box. The daisy chain also you can do it like this. Here you have a Fieldbus interface card, and through this signal is coming. So here is another Fieldbus card, and through this you are cutting. Or you can have one Fieldbus card has a maximum 32 devices. So port 1 and port 2 like this combination. So you can use port 1 or port 2, and you can have a different topology. See branch topology, daisy chain and tree. And this way point to point direct. So foundation Fieldbus communication protocol, foundation TM Fieldbus protocol is the same on both highway 1 and high 2. Highway means H1 and H2. They say H1 for H for highway and H2. So as H1 has a higher speed and H2 is a field level protocol. So therefore you will get a different speeds. So you can see here physical layer highway 2 for local and wide area network communication 100 mbps ps or 1 gbps industry standard ethernet. H1 matlab highway 1 for process automation 31.2 means this is what for a field 31.2 kbps uses existing cable power signal in these safe devices. So this is a control network H2, and H1 is process field network, and this H1 has speed 31.2 kbps, and this is industry standard ethernet control network. So here you can see this is H1 which is on 31.25 kbps, where your field devices your network, and this is your standard industry grade ethernet 100 mbps, and this is the what workstations. So that was about the foundation field bus protocol. Now we'll discuss about Profibus. So Profibus FMS for local area network communication, and up to 12 mbps at 100 meters signal. CNC devices, computer to computer like this. While Profibus DP for a devices, and it has a speed of 1.2 mbps. Distributed input output system, non-intrinsic. This is the what speed for DP. And PA, process automation, 31 point, same speed, 31.2 kbps. Uses existing cables, power and signal like this. So 31.25 is a standard, uh, as like a foundation field bus also. So among the Profibus protocol, these two are very popular, DP and PA. So PA topology we'll see here, and DP also. So device protocol, this is FMS is a control network. You can see these devices, motor starter on all electrical devices, mainly this protocol is very, very reliable and popular. DP to PA converter here is required, and on this PA, your actual process automation devices. These are electrical automation devices. So this is a Profibus topology. Uh, FMS is a control network where you have speed, you can see 12 mbps at 100 meters distance, 1.2 mbps at DP side, and field instrument side 31.25 kbps. But DP to PA converter is required here in between when you are connected to either PLC or DCS. So DP to PA converter, single point, if this fails, entire network fails. That is what a drawback of this protocol. What is a field bus? Field bus is a network device sit in a parallel between the wires. HART, you have seen, single wire goes to individual devices. Here it is a devices sit in parallel between the wires. Transmission rate is 31.25 kbps. So this is the what field bus segment. Transmitter is here, terminator is here. Sorry, I'm sorry. Field terminal. This is a terminator, and terminator electronics. You have always RC network, say RNC. This is a terminal, means you understand in the field bus network, like our normal network, Ethernet network. Terminators we use, same terminators are required here, and then you can have devices connected, like you can see a transmitter, control wall devices are there. You can have a monitor or control or power conditioner here. Power conditioner means power supply. You can mix it on this. So this is the network here. It is shown. So you can see this signal, only digital signal on this network. Only digital communication signal. So this is a very important slide for you about the field bus. H1 is a 31.2 kbps field devices. Can be powered directly from the field bus segment, can operate on wiring previously used 420 devices also. So this is the power conditioner, terminator, and this one it will work. So power conditioner basically provides the power to is the loop power. But nowadays this power condition is not required. It is a part of the card, interface card in the DCS. Earlier it was required separate power, and through that you have to terminate the wiring. So H1 field bus segment pair is two pair plus minus. Standard 4 to 20 milliampere wire pair here. Field devices powered from field devices powered from field bus through this, because this power is mixed on this signal. Power and communication on the same pair of wires. So this is what power and communication. So H1 is at a higher level. So you can see here wave shape at just a minute. Uh, H1 is for automation field devices. Actually, H1 signal transmission, wave shape at sending devices. This is a you see current. how it is 16 to 20 milliampere peak to peak, power maximum 32 volt. An equivalent circuit, as you see, 100 ohm and 1 microfarad in the terminator, and this is a device. So wave shape for the field bus for this is like this. So 0.75 to 1 voltage peak to peak. So terminator, here it is shown importance of the terminator. How you see is a trunk cable here. This is a terminator, and the cable from this junction box to the device is a spur cable. This is a standard terminology used adapted by foundation field bus. Power conditioner, ground. So RC circuit, this one, impedance matching module to prevent distortion and signal loss due to the reflection at the ends of the field bus cables. So this is normal. This function of terminator to prevent distortion on signal and signal loss. For voltage mode signal on the segment. To get voltage mode peak to peak, terminals are nickel. Power conditioner here. So ordinary power supply will absorb signal on the cable, trying to maintain constant voltage level on the cable. Therefore, has to be conditioned for field bus by putting an inductor between power supply and field bus wiring. So that is the power conditioner here, inductors. So to maintain the constant voltage, this is required power conditioner. Active filter equivalent to 100 ohms and 10 micro ohms, milliohms inductor coils. So all ground terminals should be connected to instrument ground bar or earth ground. That is the what very important. If your not device is not grounded this way, sometimes it will not work. So then segment power, you can see here power supply, power conditioner, which has we have discussed resistance and inductor coil. The terminators we have seen. So this is a signal is represented. The voltage supplied to the field bus cable can be as high as 32 volt. So you can see here the voltage at any device can be as low as 9 volt for the device to operate currently. Minimum 9 volt. So here VPS, VPC, VPS is minus VPC is less than 32 volt. Current of this device IQ1, IQ2, V1, IQ3, IQN. So you can see voltage, and VN. So here VN is a greater than for all devices 9 volt. So these are the conditions in the power supply specific, but these are coming as a standard when we call as a field bus. Then automatically the manufacturers like MTL or reputed manufacturers, DCS integrators like Honeywell, DCS or Emerson, Yokogawa, they take care of this. But as a we must know why our instruments fails. So what is the logic for that purpose? This is a uh, we uh, we must aware. If suppose we have to buy a any manufacturer, then we can specify accordingly. So if you see here wiring saving for in the field bus or in the analog transmitter, this way you can see the this is a cable trays and you see the various cables are routed here like this. Once suppose there are 100 transmitters here, so 100 cables will be there, pairs will be there. And in this place, if you switch to the field bus, then you can see 4 5 cables for this much equivalent to this, and remaining your tray remains empty. So wiring savings are the same. So common physical layer, you can see the transmitters mounted in the field. You see here, these are the transmitters, and these are the what connector here cables, yellow color cables of each transmitter. Here there are one, two, three, four, five, six, four, six transmitters you can see here, and this yellow color cable, and this is the junction box here. You see here, you can see a junction box. This is no just normally. You have to just like a ferro screws, just tight it. Like our TVs and other electronic devices, we connect uh, network cables like in our house also. When we connect to our more this Tata Sky, or there is a standard cable or fiber optic, and we insert in the box and then tight it. So same type. You can see our common network components here. This is the junction box, this black portion, and you see this is the cap. You have to replace the remove the cap, and this is the terminator at the end, right? And this is the gland. This is a transmitter, and this has a gland here, and from here you are connecting the cable straightway to this port. This is a brick. So foundation field bus architecture, three main components: field bus, field devices, one physical layer, user layer, communication stack, and this is the network, physical network. Physical layer, user layer, communication stack, and physical layer. So device communication to the network in this layer, physical layer. Protocol stacks handles the communication. This is a protocol of by foundation field bus organization. Interface for user integration through blocks through here. And key FF technology differentiators here. So physical layer. So when you compare in the OSI model, so you can see the three layers: physical layer, communication stack, and user layer. So physical layer is the foundation purpose H1 segment. You can see here physical layer composed of physical medium, wire pair, receives the message from the communication stack and converts the message into physical signal on the fieldbus wire to a digital representation that microprocessor can understand. So furthermore, so it has a Manchester encoding technique, and 31.25 is a speed. So this is the physical layer. Fieldbus signals are encoded using Manchester encoding. Data is combined with a clock signal to create a synchronous serial signal. That is what a Manchester encoding. So you can see here voltage and time. This is your clock, 1 bit per time, fieldbus message, and this is the data. And this way it is encoded. So you can see here this, and this. Again, down this. So 0 1 0 1 0 1 like this. Oh, where we are? Okay. Hmm. So this is what we are talking about, a physical layer. Hmm. Ah, we were on this slide. Now we'll go to then communication stack. Communication stack is a device communication software, provides encoding and decoding of user layer messages. Provides encoding and decoding of, because you have to again convert back. Provides a deterministic control of message transmission. Provide message transfer. So all this is a part in the communication stack. Then data link layer, as it is not separately shown, it is a part of communication stack. It's a mention which is on here. Data link layer controls transmission of message onto fieldbus through the link active scheduler, provides various possibilities for application layer to send data to other stations. So this is for interface purpose. So in the communication stack, data link layer, link active scheduler, only one LS link active scheduler per fieldbus segment. If the LS fail, backup LS will become active. So you can see here, this is link 1 or segment 1. This is link 2 and segment 2. So one LS, bridge LS here. The controller has a link active scheduler, which has entire your configuration, everything is here. Similarly, here also you have. So only one LS per fieldbus segment here, here. So traffic police for segment 1, traffic police for segment 2. Anyway, so above the communication stack is the user layer. Provides the interface for user interaction with the system, blocks, resource transfer. Means user layer will be connected through your interface card to the DCS controller for them. So blocks, resource transducers and functions. Supports device description to allow host system to know device capabilities. And key API technology differentiator. User layer resource block. So in the user layer, device means all related to device type, device revision, mode, master reset. Then in the transducer block, interface device hardware to function block, input transducer block, processing of sensor signal such as characterization timing. So what yesterday we have seen about the transmitter characteristics. So that entire thing is in different blocks here. One transmitter blocks, earlier we have seen resource block. Resource means about the manufacture details. This is about the transmitter signal characterization and timing, means your sensor characteristics. And last is output transmitter block, processing actuator and feedback signal, the output. So you can see here, as I told you, sensor, factory user characterization, unit trimming. Then functional blocks means your alarm, actuation, PIDs, measurement, control. So all these perform the basic time critical functions: measurement, control. Control means PID also there. Control selection, calculation. So user level function blocks. Function blocks can be linked together. Function blocks can be distributed to the devices, and control is distributed on the wire. Means you have an option. These blocks are available on the transmitter itself. So transmitter acts as a controller also. Your DCS controller is not there in the plant. So that is what it is done. See here, this is a workstation, this is a DCS, and this is H1 segment. And these are the you can say blocks: input, output, and this is a control. So AI 110 loop, output of this software to the input of this, then output of this PID goes to the bical of the out here, or and then the bical in, and this out is also connected. See here. So these are the tag LT108, tag DVC108, and tag DVC108. So output cascade in, like this. So you can see here, this transmitter is here in the software information available of this transmitter here. DVC is this control wall. is here, and in this positioner your PID loop is also there. This is a foundation field bus positioner of the control wall, so that carries your PID. So it this acts as a controller here, not through DCS. Though the values are coming to the DCS, like this, you can see here. See here, like this. So transmitter to the PID, and then here, and then output goes here like this. So device descriptor is a driver for the fieldbus device. New devices can be added to the fieldbus by simply connecting the device to the fieldbus segment and providing a control system or host with the DDs. Once you connect the device, automatically if the DD is available, download the all configurations to achieve interoperability, allow operation of devices from different suppliers on the same fieldbus network with only one version of the host human interface. ठीक है. So I'm going fast because these are related to the internal uh, functionality of the functional modules in the fieldbus devices. So device descriptor is having a standard device descriptor from the fieldbus, universal parameters, functional block related, transducer block. So you have a CD here, download it. So automatic address assignment is also done. A number of devices may be connected to the bus at the same time. A configuration utility in the host then automatically assign an unused address to each device. So automatically addressing is done. The user does not need to understand how to assign hardware addresses. So plug and play transmitters. So you need not to create a like go to the explorer and in the transmitter where it is connected to the which analog channel, which analog card, which controller, which network. So not required. Automatically this segment gets number, network number. This enables the fast and safe commissioning of the fieldbus network. No dip switches or software pre-configuration. What that is what I explained. As far as plus minus polarity is concerned, so here polarity insensitive device. So you see here Fisher Rosemont provides polarity insensitive foundation filter devices. Even plus minus is here. Here they have not mentioned. You can wire it anywhere. Automatic address assignment. So this enables the fast and safe commissioning of the fieldbus network. So you can see the host termination panel, rack room marshalling panel, home run cables here, wiring crossover, no problem. So you can see here online expansion, you can add the devices. So tag search, foundation fieldbus provides us services for finding services for foundation blocks by tag. So this is a tag. Variables can also be found searching tag desired parameters. So can you remember the transmitter hardware address that you are looking for? Extremely useful feature during the plant startup and operation. Unique ID, unique ID to each device. Hmm. Useful for cycle management and material management. Okay. Provides a device traceability. So these are the foundation fieldbus devices or transmitters features. So as I told, 16 values, 16 transmitters plus timestamp of last value you connect. Hmm. All devices networks share a common sense of time, which allows the precise scheduling of activities. The application clock time distribution function synchronizes all field devices. So there is no loading, or if you are load, then the device speed will affect that. That will not happen. The application time enables the device to time stamp data, variable, alarm, etc. So these are some advanced features. I'm going fast. So typical plant topology, you can see this is workstation, this is a foundation field bus network, transmitter, control wall. So you can have a discrete input, discrete output, analog output, PID, PI, proportional integral, integral control, proportional control, proportional derivative control, control selector, manual loader, bias, gain station, ratio selection. And these are the advanced functions, pulse output, interfaces and all. So this is a way the online control strategy on DCS workstation. Online, you can see here AI block, PID block, another PID, another AI. You can see the AI is input to the PID, and bical into the bical out of another PID, and the output of this cascading is a cascade in. There is another input here, analog input here, and then you can see these ratios and these are output block. So cascading of the PID loops also you can do it. So PLC based system, information mapping in PLC based system, and this is related to Profibus. Profibus bus, Profibus DP and PA. And as I told you, converter is required in the Profibus PA. So database here in the, this is the foundation field bus architecture, and this one is a Profibus architecture. So database is here, here is the same. However, the database here and here is the same. So foundation field bus host database locations. Okay. Interoperate with the different vendors. I'm skipping this. Full device description supports enables you to upgrade function purpose devices by downloading the new DDs. Always you see new device comes, so you have to download device description file first. Device from vendor A, device from vendor B. So always it is you have to download. Mm. To upgrade Profibus PA, there is a different methods. Find out which PA communication profile it is using, version 1, 2, 3. Then find out if the hardware of your device can support the new PA communication profile. Check the host PA communication file. Then return the device to the factory for the device to be upgraded. So that way PA has some limitations. So device status, you can have this device and this is a workstation. Value, status good or bad, substatus description of the fault, limits high, low, constant or not limited, predictive analysis, impulse line plugging. So these types of device related diagnostic is available in the foundation filters. So all connected variables have a status reflects the measurement health and predictive data device failure analysis. So predictive device failure, for example, this is a flow transmitter, orifice plate, sensing line, manifold, pressure transmitter sensor here, and here this line downstream means your upstream and downstream line plug it has been blockage, choke. So what happens in your foundation field bus diagnostics with advanced diagnostic function, you can we can predictively detect device failure. This can be applied to the primary sensing element, the transmitter or the final actuator. So you get this types of errors here on your workstation, DCS workstation. So there are few exercises. Thanks. So that's all about foundation field bus for today. Hello.
Ah, yes, sir.
Foundation field bus we have finished now.
Okay, okay, sir.
So
Okay, so today's
only
session is finished. We will
So
meet tomorrow at 10 a.m.
but
Okay.
only wireless is a balance. So can we continue with wireless or we have a separate session for this?
As per
Wireless.
your convenience, sir.
ठीक है. So tomorrow we'll continue transmitter in the wireless. What are the features now, right?
Okay. Okay, sir. No
Uh,
problem.
ठीक है. Thank you. You just tell me tomorrow's timing. Just
10
message
a.m.
me.
10 a.m.
10 a.m. Right.
Hmm.
Thank you. Thank you,
Okay.
madam. Thank you all.
Thank you, sir.
Thank you.